So basically, we will discuss today about the basic flip-flops. We will discuss about first one is SR flip-flop, and we will discuss about the next flip-flop, which is nothing but D flip-flop, and we will discuss about the JK flip-flop, and we will discuss about the toggle flip-flop. These are very much important for the exam point of view, as well as for you to study the upcoming subject. So in order to do all these things, first let's try to discuss about basic. So these four are called as flip-flops. So in order to define these flip-flops, we need to first understand about latch. Okay, so latch means it's nothing but we can call this latch as an 1-bit memory storage elements. So latch is nothing but an 1-bit memory storage device. So latch is basically this latch will exhibit an bistable in nature. It will give an two stable states. This is an bistable element. Bi means is going to have two stable states. What are those two stable states? Means one is Q and another one is Q bar. So these two are basically output is complementary in nature. Okay. So what is meant by complementary in nature means if Q is 0, then Q bar will be 1. So therefore, how many states you are going to have? Two stable states you are going to get in an latch. And this latch will generally store either 1 or 0. That is what the meaning of an latch. Now let us try to see an basic latch. So in the latch we need to perform, then we need to have and one more input where this is called enable input. This enable input is called as a gate. Okay, so this what this latch will work. So generally latch means how I can say it's for example, you will lock the door. When you lock the door, then it stores 1. When you unlock the door, then it is 0. So they are going to store until if you lock the door means you are getting the value as 1. If you unlock the door, then it is 0. It's like latch is also like a lock of memory values. That's called 1-bit memory storage. It can store either 0 or it can store either 1. And how many states are there means 2 states are there. Now I will discuss the basic one and we'll go into the further. So here the latch design is like this. Okay, so here we are going to have an inverter and you are going to get the output. Let's try to define A is equal to 0 here and one more input B is equal to 1 here. And here I am going to design an basic latch with two inverters. So the output of A is connected to the input. I mean input of A is connected to the output. So this is one design. And see output of A is connected to the input. Then this is going to give you an output. One is Q and another one is Q bar. So for example, Q1, Q bar are basically two stable states. So here we are going to have two stable states. Whenever you are having two stable states, then it is called as a bistable element. Therefore, this latch is called as a bistable element. Now let us try to learn the operation, how it works. So we had how much we have been given here. So what kind of operation this is? AND. Okay. So when you give 0 here, what is the output you are going to get? When you give 0, what is the output you are going to get here? 1. So this 1 will come to here, and now what is the input of this inverter is 1. What is the complementary of 1? You are going to get 0. So we applied 0, and what is the output we had got? 1. So therefore the output is nothing but now Q, and 1 we had given the input to the B, and you're going to get the output as 0, and this is nothing but 0. So the way of interconnecting one inverter with another inverter, this is called as a cross coupling. So this is called cross coupled inverters. So like this, we can interconnect NAND gates, NOR gates using rather than using an inverter here, we can use AND gate, can use an OR gate also. Okay, so that's why it is called basically an latch, where two inverters or the two AND gates or two OR gates are cross coupled. And how many inputs are there means two inputs are there. Here you are going to have two outputs, and these two outputs should be both should be complementary in nature. So if one is 1, automatically another should be an 0. So both should be complementary in nature. Then you are going to get two stable states. Therefore, a latch is called as a bistable element. So this is what a basic behavior of an latch. So can you say the one more example of the same latch? Okay, here I'm going to use AND operator, and here I'm going to use one more AND operator, and here I'm taking A is equal to 1 and I'm taking B equal to 0. So the output of A is connected to the input and the input is connected to the A. I'm going to get stable state Q and another stable state Q bar. So can you say the output now? Here what is the input applied? 1. What is the inverter of 1? 0. What is the value of Q now? 0. And we had taken this 0 and we had applied to this input. What is the input now available? 0. So 0 is given. What is the output now? 1. So what is the output now? 1. So how many stable states are there? Two stable states are there. So this is basically this kind of behavior is called as an latch, where it exhibits two stable states and both are complementary in nature. So please write down the notes. Just draw the diagram and just write down how these latches will work. This is basically all about latches. Okay, completed.
Yes, sir.
Okay, dear students, please respond. Why? Because no, actually, I don't know whether you are listening or whether you are watching the mobile or not. So I require your cooperation to conduct the class as simple as and as easy as possible. Okay, everyone has drawn the diagram.
Yes, sir.
Yeah.
Yes, sir.
I repeat again. This is very important. What is meant by a latch? Latch can store only one bit,
By
one bit memory storage. Either 0 it can store or it can store 1.
one.
This latch generally is an bistable element. Bi means how many? 2. How many stable states are there? One is q, one is q bar. Therefore, this latch is called as an bistable element, and the output should be definitely complementary in nature. Okay, so that what you have to understand. So if this latch has to work means you have to give one input. That input is called enable input. Okay, that is called also as gate. So now we'll try to discuss about very important. This table you first remember in your brain, and we will be verifying that whether you are getting this or not. Okay. Put the first subheading yes or flip flop. So put the subheading yes or flip flop. So what is meant by flip flop means a flip flop is also an one bit energy, I mean 1 bit memory storage device. So this will also store the 1 bit memory storage element. So now I will show you one table. This table you remember, and we'll try to do the proof whether you are getting this table or not. This you should remember at any cost. If I ask you this table and randomly also, you should respond. Now let us try to take how this table is constructed. So I'm having the first input is yes, another input is r, and one more input is nothing but q1, where S is called as a set. S means set. R means reset.
Reset.
Reset means generally 0 and set means generally 1. So here where Qn we are going to call it as the present state. These terms you have to remember. Qn means present state. And next you are going to get the output, which is nothing but let me write down with another color, you'll get a clarity. So the next state is nothing but qn plus 1. Okay, so this is what you're going to get. So try to draw an line. So how many inputs are there? How many input variables are there? So these are called as inputs. These are called as output. Now all these flip-flops you are studying, this is sequential circuits or combinational circuits? Flip-flops is an example of sequential or combinational. Sequential. Why? Because basically these are an memory storage elements. So how many inputs are there? 1, 2, 3. How many possibilities we will be getting? 2 cube. 2 cube is equal to how much? 8. How many possibilities you are going to get? 8 possibilities. Therefore, we are going to write down the decimal number here. So thank you for your cooperation. You are giving the response which makes the class to teach well. So how many decimal numbers you have to write down? 8 decimal numbers. What are those decimal numbers? They will start with 0. Next one, 1, 2, 3. So we will put one line. Okay. Okay. First we will put one line for first 4 digits, and next we will put line for 4, 5, 6, 7. So totally 0 to 7. How many possibilities are there? 8 possibilities are there. First you have to draw it. If you draw this table, definitely you will get full marks. There's no need to write any theory also, but you have to remember this table. So now 0. So what is the code behind this 3 decimal? This is nothing but 2 4 to 1 code. Okay, so 2 to the power 0, 2 to the power 1, 2 to the power 2. How to write down this decimal 0? We can write down it as 0, 0, 0. How to write down 1? 0, 0, 1. How to write down 2? Anyone? 0, 1.
0.
How to write down 3? 0, 1, 1. And again, we will try to draw one line between the remaining two. Okay. I will draw one more line between these two again. Next, and for this also, I will draw one line. Okay. So now coming here, how to write down 4? 1, 0, 0. Good. How to write down 5? 1, 0, 1. How to write down 6? 1, 1, 0. How to write down 7? 1, 1, 1. Okay. Now you see here, we need to get qn plus 1, where qn is called present input, where qn plus 1 is called the next input, what you're going to get. So this is nothing but next input. I had already told this is a sequential circuit. We will get the input from there, present input, and you'll get one more input from where? Previous input. That previous input is called the next input, which is like an feedback. Now how we are going to get this, you remember? So the value of Qn for these two combination, we are going to get Qn plus 1 is nothing but next state is equal to the present state. What is the value of Qn plus 1? So for example, take here, this is 0 state, this is first state. Okay, so Qn plus 1 is equal to how much? Qn. So what is this? Qn is equal to how much? Qn. What is the Qn value here?
0.
0, 1. This you have to remember at any cost. First half, Qn plus 1 is equal to Q1. And the next state, for the remaining 2, you are going to get the value as a reset. Reset is equal to how much? Reset means how much? 0.
0.
The output you are going to get it as a 0, 0. And next one. So for the next two combination, you are going to get the value as a set. Set is equal to how much? 1. So here the output you are going to get 1, 1. And the next one, you are not going to define where it is called as a indeterminate state. So this state is called indeterminate state. We cannot determine what is there on this whether it output is correct. So this is called invalid output. So this indeterminate state is called, this is an invalid state, or this is also when you do the K map, define this K map, we are going to call this invalid state as an don't care condition. Okay, so this is called don't care condition. You should not care whether the output you are getting or not. So this is called a don't care condition. So I repeat again. So what are the combinations? This you have to remember at any cost. Then only you can solve remaining flip-flops. What is a flip-flop?
1-bit memory,
Memory storage.
1-bit memory
Very
storage.
good. What are the inputs you are having? S, R, Qn. Where S is called as, okay, where S is called as set. Where R is called as reset. Where Qn is called present input.
Present state.
What is the output you are going to get? Output is called as Qn plus 1. This Qn plus 1 is also called as the next input.
Next input.
Or this we are going not next input, this we can call it as next state. So how many inputs are there? All zeros. Next one, 0, 0, 1. For these two combination, what is the output you are going to get? Qn plus 1 is equal to Qn. For the second combination of decimal 2 and 3, what is the output you are going to get? 0.
0, 0.
For the next decimal of 4 and 5, what is the output you are going to get? Set.
1, 1.
For the next 6 and 7 decimal combination, you are going to get where this is called invalid. I will teach you later. Here, if you get both 1, the system cannot understand. If you get both inputs as 1, our system cannot understand. Here also, both zeros also is there. These two are called invalid. I mean, these two are called not needed. We don't need these two conditions. Therefore, we will design the next flip-flop. So, hope you first write down this table. And now, the thing is, if you are able to by heart, is well and good. You don't need to study the subject. But if you ask me, sir, I don't want to by heart. I want to know the logic, how I am getting the output. Now I will show the proof for one. The remaining you try to do of your own. Okay. So first everyone write this table. Okay, done.
Yes, sir.
Yeah. Shall I proceed with the how we are going to get this output?
Yes, sir.
Yeah. So see that what the first state is called Qn plus 1 is equal to Qn. Second two inputs are called reset. Next one is called set. Next one is called indeterminate. Okay. Now put the main heading SR latch using NAND gates. I mean SR flip-flop using NAND gates. SR flip-flops using NAND gates. So we can design this SR flip-flop using NAND gate is the first one what we have in the syllabus. We can design an SR flip-flop using NOR gates also. Okay, so these are two what we have in our syllabus, two NOR gates. Okay, so we'll discuss about these two, and from these two we have to get the same output. So first SR flip-flop using NAND gates. This is very much important. Now when you come to this NAND gates, now let us try to take here. I'm having one input and I'm going to perform negation and I'm going to get one output. So here also I'm taking one input and I'm going to perform negation and I'm going to get the output. Okay, so these are called as inverter gates. And from these two inverter gates, I'm going to get one NAND gate. So this is nothing but one NAND gate. This is another NAND gate. And these two NAND gates are interconnected with, I mean, they are cross coupled. This is one cross coupling. This is another cross coupling. Please listen carefully. If you understand this logic, you can crack this exam. Okay, so here you are going to get the outputs as we will give the first input is q1 and the next input is nothing but qn bar, and we need to get the outputs as qn plus 1 is first one and another one is qn plus 1 bar. So how many states are there means two states are there, therefore this is called as an bistable, or we are having two stable states. Since you have two stable states, it is called as an flip-flop or it is called as an latch. Now let us try to see here. So now let us try to see our first combination. S is equal to 0 as well as R is equal to 0. Okay, and we will try to see here. So S is equal to 0, R is equal to 0. First combination. S is equal to 0, R is equal to 0. And what is the value of Qn? What is the value of Qn? 0. So here I am writing that value as 0. If this value is 0, what is this value? What is this value? 1. Complementary, no, we have to get two stable state. Now what happens? Let us try to see here. We applied 0 here. Okay, what is the output you have to get? 0 I have to get. Let's try to see whether we are getting or not. So we applied 0 here. When you do the inverter, what is the output you are going to get? 1. Okay, so here what is the value? 0. When you perform the output, what is the output you are going to get? 1. But which AND gate you have to consider first is if from S and R, if you get 0, consider it first. Or from, so I mean, second probability, this is the first probability, directly from S, if you are getting 0, that you have to consider. Or the second probability is either from Qn states you are getting 0, then you should consider the NAND gate which has 0 input, which has 0 as the input. So do you have any 0 input here? What is the input here? 1. What is the input here? 1. So we cannot solve this problem. Then what you have to do is, so Qn is there. What is the value of Qn here? 0. So this Qn will move here and we will be going to get and 0 here. Okay, small modification here. This will be connected as a one more input. Okay, so what is the one in first input? 1, and another input from Qn, you are going to get the 0 here. So this is which gate we are studying is NAND gate. Can anyone say the table of NAND gate? So first input is S, another input is R, and let's try to perform S into R, and we are going to get the complementary of this one is NAND gate. This is AND gate. Okay, so this also you have to write down side when you want to solve. If you understand one, if the examiner asks derive, then you have to do this. Definitely they will ask only derivation, no one will ask the table. Okay, so how many inputs are there? Two inputs are there. What are the decimal numbers combination? 0, 1, 2, 3. How to write down the NAND gate? 0, 0. So this is nothing but 2 uncode. 0, 0, 0, 1, 1, 0, as well as 1, 1. What is the product? SR. Please respond. Is the connection available for you? Hello?
Yes, sir.
Yeah. S into R is how much?
0,
0,
0,
0,
0,
0, 1. What is NAND of this one?
1, 1, 1, 0.
1, 1, 0. So please be active in the class. Please don't sleep. In this your life, you have to pass the subject. It's very, very tough and very easy also if you understand the logic. So what is the NAND gate you are getting is triple 1 and 0. Now you see here. So what is the input we have here? One input is 1 and one more input you got from Q1 is how much? 0. So now when one input is 1 and 0, so check out when it is 1 and 0. Okay, what is the output you had obtained? 1. So 1 and 0 combination, what is the NAND gate output? 1 we had got here. Okay, and so this first NAND gate we have been executed, and this 1 will go to this state, and 1 will be viable. So this NAND gate we are going to solve the second time. Okay, so now how many ones are there? How many ones are there? One input is 1, another one is also 1. When this you forget, just you forget this. How many inputs are there? 1 and 1. What is the output? 0. So here you have got the output 0. So when you perform this input as, so what are the inputs here? 1, 0, you have got the output as how much? 1. So this 1 will be our next state, which is nothing but Qn value is how much? 1. Okay, so this 1 we have been taken here. 1, 1, what is the output you have got? 0. This output will be available as a Qn plus 1 is a 0. Okay, so now this is Qn value is how much? 0. Qn plus 1 is how much? 1. Both are same or different? Both are different means both are complementary in state. Both are complementary in nature means both are having how many stable states? This is one stable state, this is two stable state. Since it is satisfying basically two stable state, this is a valid flip-flop. Okay, so that's how you can see here. What is the output we had got now? Qn plus 1 is equal to how much?
0.
Qn plus 1 is equal to 0. Qn is also 0. What is the statement I can write down here? Qn plus 1 is equal to Qn plus 1 is equal to how much? Qn. You see that condition is satisfied here. What is Qn plus 1? 0. I mean Qn value is how much? 0. What is Qn plus 1 value? 0. So this we had done now. Okay, by taking S equal to 0, R equal to 0, and Qn equal to 0. When you are doing this flip-flop, how to write down the sequence in a NAND gate, especially is SR flip-flop you're writing. First one, we should write down S, and second element you have to write down R. First element should be S, and second element should be R. In the case of an NAND gate, we'll reverse in NOR gate, that will think later. Okay, and this is like now let's try to do the same calculation again here. Okay, so now let us try to take one more one more inverter gate, and here we are going to have one more inverter gate, and we are having the NAND gate. So this is how we have the NAND gate, and this is output, and this is one more output. So we need to cross couple. So the output is connected to input, and this output is connected to input. Okay, and what are the inputs you are going to give here? First one is called Qn, and another one is called as Qn bar. Okay, and here let us try to give the inputs. First you have to take which input? Yes, and another one you have to take R. Okay, so let's now implement for the first term only. Okay, so now previously we taken S is equal to 0, R equal to 0, and Qn equal to how much? 0. Now we will take S equal to 0, R equal to 0, Qn is how much? 1. Okay, so Qn value is how much now? 1. What is the value of S? 0. What is the value of R? 0. Now let's try to implement. Here what we have been given? 0. What is the output of an inverter? 1. Here how much we had applied?
0.
And what is the output you are going to get here? 1.
1.
But which gate we should solve first is, so directly from S and R I should get how much? 0. It is not getting. First case fail. And either from one more input like a Qn, I should get one input as how much? 0.